we have what promises to be a bit of a stretch here. So I'm going to add 1 to both sides, and then I'm going to multiply both sides by the denominator. So I'm going to end up with cosine 2x is equal to sine 3x minus sine x, and start from there. Alright, so on the left side we recognize cosine 2x, and we'll write down cosine squared x minus sine squared x. We have a couple options on that, but that's the one we usually choose. And not saying you couldn't look up some other ones. Then there's another one. I can write the sine of 3x. I can write that as, well, let me write it out like this. The sine of 3x, we'll say it's equal to the sine of, let's say 2x plus x, okay? And if we say that, then we can use the sum and difference formulas, and we can say the sine of 2x plus, I'm reading it off here, cosine of x plus cosine of 2x, the first one, times the sine of x. Okay, and I'm going to put that in there for that. So I'm going to say the sine of 2x times the cosine of x plus the cosine of 2x times sine of x, and then minus sine of x, because just so you don't forget that part right there, I just had to tack that on to the end. Alright, so then we can go further, and we can say on this side, we'll say the sine of 2x is the same thing as 2 sine x cosine x times cosine x, plus, as we recall, cosine squared x minus sine squared x times the sine of x minus the sine of x. Okay, now at some point some things are going to have to dawn on us here, because this is getting kind of stretched out. Not too bad yet. So let's see. I suppose, should we go ahead and multiply this out? We know we've got a sine x for everything on the right, so that seems kind of tempting. We could say, we sort of have to explore, don't we? So we'll say the sine of x out in front of what's left inside, 2 cosine squared, there's 2 of them multiplied together, and since I took the sine x out front, now I can just write this as plus cosine squared x minus sine squared x minus sine x. I had failed to take out the sine out of this term right here, so I went back and I took out the sine, and now I have a 1 there. So if you don't do that, problems arise. You will not be surprised. So let's see. I think what I'll do before I write that other side is I will say, well, let's go ahead and say this. Sine of x times, and I'll collect my cosines, and that's going to be 3, right? So I was thinking about doing 2 steps at once, but maybe not. I want to be efficient, but I don't want to be crazy. So because there's a sine out in front, I think what I'm going to do is change everything to sine. I guess I could have done it the same way with cosine, but it's just easier with this sine right here. I'd have to change that too. And I'm going to change this to 1 minus sine squared x. I just think that's easier because of the Pythagorean identity. I'm just going to do that for both of them. And I will say 3 times the 1 and 3 times the sine squared x. I hope that's okay. I kind of skipped a step there. I substituted in for cosine squared x 1 minus sine squared x. And then I have another sine squared x, and I have minus 1. Okay, so now I have 1 minus 2 sine squared x is equal to sine x. And if I get this all together, I would say now I have minus 4 sine squared x. And, okay. I was thinking this was going to be a little different, but it's not, so there we go. Earlier, when I didn't get rid of the sine, I had a middle term, but now I don't have a middle term. Okay, so that's interesting. Alright, so let's move everything over to one side and multiply out. Who knows? We might get lucky. We'll say sine x. I'm going to multiply that out. Oops. I'm going to say negative 4 sine to the third x minus 2 sine x. And then I'm going to bring these other guys over. I'm going to say negative 1 and plus 2 sine squared x. I get everything on the same side, so now it can equal 0. And when I look at this, I'm just seeing if this is going to work out nicely. Who knows, we might be able to use grouping, and that would surely be nice. You know, I'm an optimist, so I kind of hope something like that would work. This is a contrived problem. Somebody built this problem, so it's not entirely just the fact that I'm an optimist. I'm also a realist. So let's take out 2 sine squared x, and I guess we'll make it... No, that's not going to work because we have different signs. That's too bad. Oh wait, that's a plus 2. Ah, another mistake. Okay, so 3 and minus 1, so that's a plus 2. So what does that mean? This will be plus, making amends here. So that'll be plus. Okay. Alright, so that could still work. I thought because of the signs there was no chance, but since I messed up on the sign, here's where I messed up on the sign. I had 3 and I had minus 1. Okay, so that's going to be a plus 2. And then I get plus 2 sine x. And, yeah. Alright, so far so good. We got that. Alright, I just want to make sure I had it right. Okay, so let's factor out a negative 2. And that will leave us, oh, not more than that, sine squared x. Okay, and that leaves us with 2 sine x plus 1. And then I will factor out, is it plus 1? No, it's minus 1. Minus 1. Boy, you know, if there's a way to mess this up, I think I'm going to do it. I take out the, so the first one's positive, second one's negative, and then obviously I have the same thing. And this is what I was hoping for, but boy, I sure was stumbling around in the dark. Not in the dark entirely, because I was hoping this was the case. So factoring by grouping does work, which is a real relief, because otherwise I have, you know, algebraically I have x squared, x to the third, and that's a lot more difficult to deal with, and I was kind of hoping I wouldn't have to. So now I've got it factored as, how shall I write this? I'll just go ahead and say 2 sine squared, negative 2 sine squared x, plus the 1 here. These guys together. And then 2 sine x minus 1. And it's factored in, isn't that nice? And this is the difference of 2 squares? No, not quite. Pretty close. I guess I'll just go ahead and solve it for 0. So we will say that negative 2 sine squared x is equal to negative 1, and then we'll divide by negative 2, right? Okay, so sine squared x is equal to 1/2, and then we take the square root, so we're going to say sine of x is equal to plus or minus, eventually it would be square root of 2 over 2, right? Or you want to say 1 over square root of 2, that's fine. But either way, I'm looking at 45 degrees, so I'm going to say x is equal to pi over 4, 45. Doesn't matter what quadrant I'm in, so I'm going to list all the 45s from 0 to 2 pi. These are all the 45s in each quadrant, all 4 of them. Okay, so those are possibilities. And then I also have 2 sine x is equal to 1. Move the 1 over. And now I have sine x is equal to 1/2. And it's a positive 1/2, and there's no squared business going on here, so I'm going to say that x is equal to pi over 6, because that's 30 degrees, and also 5 pi over 6, because quadrant 2, it's also positive. So I'm looking at 6 answers here, and I will post a picture of the graph to confirm or deny. And if I have to deny, then I'll go back and change it, of course. But I will post a picture of the graph, hopefully confirming this as true. So here's the addendum that I'm tacking on. I said I would graph this, and I did. And when I graphed it, this is what I got. Only 2 of my solutions show up. I thought I had 6 solutions, and I only get 2. When I graph them, I say, well, what's wrong? And I think, well, if you recall, if you look up here, the denominator is sine 3x minus sine x, and it would be bad if that were 0, right? Well, these guys over here, yeah, that's going to give me zeros on the bottom. And to demonstrate that, I will say, remember the bottom is sine 3x minus sine of x. Okay, what happens? Let's just plug in pi over 4. I get sine 3 pi over 4 minus sine pi over 4. Well, 3 pi over 4 is in quadrant 2, so it's still positive. It's the 45 degrees, so the sine of 45 is square root of 2 over 2, and it's also positive in quadrant 1. And when I do that, I get 0. So that's not okay. It's a solution, sure, but I can't allow it because it makes my denominator 0. You say all of them, and of course the answer is yes. Let's go ahead and fast forward to the 7 pi over 4, and we'll multiply that by 3, so we'll say 21 pi over 4, and we'll subtract sine of the 7 pi over 4. Okay, so this is what happens when and they're all like this, but I just want to show. So I have a little bit of extra here. 16 over 4 is 4 pi, and that's 2 times around that I don't really need. So if I get rid of the 16 out of 4, I'm going to be left with 5 pi over 4, which is the same angle, the sine of that, minus the sine of 7 pi over 4. Okay, so I don't need to go around twice just because. You guys see that, right? 16 pi over 4 is the same thing as 2 pi. Well, it's 4 pi, but it's the same as 2 pi. Okay, so maybe I shouldn't say that. Anyway, you get the idea. It's 4 pi, which may as well be the same as 2 pi. It's a round extra for no reason. So 5 pi over 4, sine's negative in quadrant 3, so I get the square root of 2 over 2, but it's negative. Then I'm subtracting, it's negative in quadrant 4 as well, so I'm going to get the square root of 2 over 2, but it's negative, so 2 negatives make a positive, so I end up with 0 again. So for all 4 of these answers over here, they're not going to work for me because they're not in the domain. I can't put them in. But these guys are fine. I'm okay with these guys. They work out just fine. So the graph shows me without me doing a whole lot of checking, although I guess I could have checked that pretty easily.